Welcome everyone to our webcast today. My name is Andres Abeta. I'm the Executive Director of Bootcamp GIS. I have with me David Foster, a Defense and Security Geospatial Consultant, who is the co-chair of the SAME, Society of American Military Engineers Geospatial Working Group. Thanks for joining me, David.
Andres, it's great to be here.
Thanks for our audience for joining us and coming to hear the talk about geospatial data sources that every engineer uses. This could be in a lot of different contexts of different types of projects, but engineers are engineers. And one of the first things I want to ask you, because you have lots of experience in this area, is what are great data sources that are vital for situations in which there's a disaster before you?
Engineers in general use, starting from the foundation up, right? Let's talk about survey data. You got to know what the terrain looks like. You got to know what the soil composition looks like before you start building on it. Then you've got drafting and design, or computer automated drafting and design, or building information models that then turn 2D into 3D. You've got geographic information systems, or any type of GPS data collection device that is able to generate data and document data about the location you're on. And then you've got satellite imagery and light detecting and ranging. All of this information integrated together helps engineers actually plan and execute whatever it is that they're doing, whether it's constructing resiliency projects along the shoreline, dredging of a major waterway, ports, developing ports, or building an air base in the middle of another expeditionary location, or whether you're building a power plant in your local community. All those types of data help engineers build America strong.
So there are different types of data. Are they packaged together in certain portals where you can have a URL and go just grab it?
That's going to be dependent upon your organization. However, foundational data, if you're looking at baseline information, if you're within the continental United States, the Homeland Infrastructure Foundation level data committee, they actually have it's called Highfield. They have a Highfield data set, which is a great starting point for access to foundational data within the continental United States.
Oh, that's great. So when you have a central data source that is available to you, how is it distributed by your organization? Do you find that on a geospatial webpage or emails? I mean, that's really important for people to know where to get the data, right?
Yes. The word depends. Depends on your organization. We in the past been taught this term called sneaker net, and sneaker net means that it's an external hard drive. The data that you have could be a terabyte in size, so it's not very easy to push across networks that are constrained for whatever purpose. So you sneaker net it, or you FedEx it to somebody, or you drive it across town, drive it across the base camp. So there are, from that level, smaller data sets. Certainly you could email, shared drives, Dropbox type capabilities where you're doing larger data sets over the internet. And then you've got applications, and there's different types of applications that are created by industry to upload and share data almost in real time, either through basically an online geodatabase, or actually through a portal service. And a lot of this can be done through data services. So create the data, you upload that data service, and as you're changing the data and posting it, it updates anybody that's connected to that data service. And those come in many forms: web feature services, web mapping services. I'm trying to think of all the different WCS, WMS, WFS, all these different types of data services that enable the seamless sharing of information. So all those are available, and how you use them is, or any organization does, is up to them. And a lot of the constraints come around information assurance or cybersecurity. Again, depending on your organization, whether it's private industry or the military, protecting your information is an important thing. And so certainly conversations with your cybersecurity teams and your information assurance teams would be had to see which ones it would best suit your organization.
Yeah, if you're an existing GIS analyst, you're going to know about most of the GIS data sources that are available to you, because that's what you do day in and day out. If you're an engineer kind of coming in and getting accustomed to being in that role of putting together geospatial products, this is something to learn about all these different types of sources, and asking questions to people around you about where you do get access to data. But the answer is a variety of sources, just like David just mentioned. And that's really the way of the world, because there's so much information out there. And that leads me to my next question is, what do you see are some examples of really having now to rely on good local data, especially like in a disaster? I heard of one project or an application that was stood up in the during the event of Hurricane Katrina, where they had a web app that was capturing mobile communications by all these people who were sending out distress calls in the event, and you could actually pinpoint where the GPS coordinates of those calls were, especially to help rescue people.
Yeah, so wow, and things have continued to only improve with mobile device applications, crowdsourcing, if you will, right? Been lots of efforts either through the international crisis mappers or organizations like Ushahidi, Humanitarian OpenStreetMap, or private organizations that are other NGOs that are creating applications that are able to either have a field data collection app or have an online presence, allowing people to add content as things are happening. You can go in there and update, going, this is what I'm seeing. Those are all capabilities that continue to improve and are quite helpful. But looking at other data sources, again, we've talked about static data versus operational data. And a lot of the static data is available through stuff like the geoplatform.gov, the Homeland Infrastructure Foundation level data committee. There's a Highfield Open and Highfield Secure. So the secure side, you have to request access and have a reason for accessing it for government purposes or in support of government missions, because some of this data is either proprietary or there's a security reason why that they want to know who you are and why you're using it and how you're using it. Homeland Security Information Network also is a great source. And then there's a thing called the National States Geospatial Information Council, GIS inventory. And it's just another great resource. And those are all, in many cases, those are aggregating or putting into one location a whole bunch of data from hundreds, if not thousands of sources of information. And most of them are broken down into categories, agriculture, communications, transportation, medical, law enforcement, security, power generation, things like that. So they're pretty easy to navigate. And from there, some of them have data services, which if you've got a great geospatial capability, you can just automatically, basically tap into those data services and get those live data feeds. Or there's static data, which then you can ingest into your own geodatabases for whatever purposes that you need.
Yeah, you mentioned a lot of those, and those are good for some standard data sets that are like streets and political boundaries. Do you have any other sources that might be a little bit different that are good for construction logistics?
Well, Really the same thing. If you're talking emergency management, I'd start there. But for construction, go to the facility manager or the engineering department, director of public works, the Department of Transportation. So if you're talking about a county or a state, everybody's got a Department of Transportation, some form of director of public works, the engineering guys. Those are great places to start. They're going to have foundational data. They're going to have the survey data, the imagery, the LiDAR, CAD drawings, 2D planimetric maps, all the things that an engineer would need to plan a project. And I'm trying to think also real property offices, your county or city, the people that do the meets and bounds, the property lines, and your tax assessors. That's what I'm thinking about. Your tax assessor has pretty good information about property lines and ownership and other sundry data elements that are important to good government.
Yeah, and that will include more than just things. It could be live stuff or protected stuff like sensitive species that could come out of your county data sets, as well as cultural resources, which are usually state governed, archaeological sites and protected historic landmarks, stuff like that. Well, this is great. I really think that the knowledge of data sources is something you have to stay up on top of. It's changing all the time. There's new data sources, there's new data coming in, and it's not learn it one time and forget about it. Nowadays, there's a tsunami of data being created every day, as I heard you say before, and so it's a really challenge that an organization or an individual within a geospatial group needs to stay on top of.
And it's a challenge. It's a good thing. It's a good problem to have. Too much data. But if you don't have a plan if you don't have a plan in place, you're going to be paralyzed. You're going to be paralyzed by that tsunami. You're just going to be staring at it with your mouth, down to your ankles. Where do I begin? But just ask yourself the question, what is my job and what's my mission? And I've got a starting point now. Andres and Dave talked about it. Go see my local DPW or Director of Public Works, or look online at some of the federal resources that are available. And from there, the world just starts opening up. And if you're not a geospatial professional, we've been talking about the engineering community. If you're an engineer and you really don't get this and you don't even know how to spell GIS, it's okay. It really is okay. Just go ask the people that you now know are your experts. Go see them, and they'll lead you down the right path.
Yeah. And it reminds me also, I've written an article that's entitled "The 5 Key Reasons Why the Geospatial Industry Continues to Grow." And it's this proliferation of data is one of the reasons. When you have more data, you need more people spending more time managing it and extracting some actionable knowledge out of the data to make it worth anything. So anybody on this call who's interested in the geospatial career path, it's certainly a growing and a very practical career path to follow. And one way that you can get into that is by coming and taking a look at our courses, at our course catalog that lists individual skill sets that are based on industry workflows, in disaster risk response, emergency management, urban planning, lots of different really applied areas. And so you could take 1 class or 6 classes in route to getting a GIS certificate. So come take a look and give us a call if you have any questions. We appreciate your time, David, for showing your insights from the engineer's perspective.
It's been my pleasure. This conversation with you is always fun and enlightening. Going back over my own experiences in my own head is a good thing for me personally. So I appreciate the opportunity, not only for myself, but then for others who are listening to us. So thank you.
Yeah, thank you. All right. Talk to you later.